On the 30th of January 1943, Hermann Göring stood at a microphone in Berlin, preparing to deliver one of the most important speeches of his career. It was the 10th anniversary of the Nazi Party's rise to power, and the entire ceremony was being broadcast live across Germany and much of occupied Europe. Millions of people were listening. Göring cleared his throat, adjusted his notes, and began to speak. And then from somewhere over the city, air raid sirens started to wail. The broadcast cut out. In a country that had built the most advanced air defense network in the world, at the exact moment its most powerful public spectacle was being transmitted to the ears of an empire, 3 aircraft had just flown directly over the capital in broad daylight. They dropped their bombs, turned around, and disappeared into the western sky before a single German fighter could get close enough to fire a shot. There would be a second raid that same afternoon, timed to interrupt the speech of Joseph Goebbels. It would also succeed. It would also go unpunished. These aircraft were not the massive 4-engine bombers the Germans had been preparing to defend against. They were not made of aluminum, they carried no defensive guns, they had no gun turrets, no waist gunners, no tail gunner, no ball turret underneath. They were built almost entirely of wood, and in many cases they were assembled by carpenters, furniture makers and piano manufacturers who, 3 years earlier, had been building bedroom sets and grand pianos for the British middle class. The airplane that had just humiliated the head of the Luftwaffe on live radio was, in the strictest technical sense, a piece of furniture with 2 engines strapped to it. Its name was the Havilland Mosquito, and by the end of the war, it would become one of the most feared, most respected, and least understood aircraft in aviation history. A plane that the Air Ministry had rejected 3 separate times. A plane that senior officials mockingly called Freeman's Folly. A plane that engineers on both sides of the Atlantic insisted could not possibly work. A plane that ended up being faster than the Spitfire, more accurate than any heavy bomber, more versatile than any single-role fighter, and, mission for mission, the safest aircraft in RAF Bomber Command. This is the story of how a company that started in the aviation industry ended up handing the fastest bomber of the Second World War over to Britain's furniture and piano makers. It is the story of a father who lost a son to the very machine he had invented. It is the story of an idea so unconventional that the men who ran the Royal Air Force spent 2 years actively trying to kill it, before finally being forced to admit that it was, quite possibly, the most brilliant aircraft design of the entire war. And it is the story of how a piece of wood, glued together in a workshop in Buckinghamshire, humiliated one of the most technologically advanced air forces the world had ever seen. To understand how any of this became possible, you have to go back to the year 1938 and to a man named Geoffrey de Havilland. De Havilland was not a bureaucrat, he was not a politician, he was one of the most experienced aircraft designers alive, a pioneer of British aviation who had been designing airplanes since before the First World War. His company, the de Havilland Aircraft Company, based at Hatfield in Hertfordshire, had already built some of the most successful civilian aircraft in the world. He had a particular obsession, one that separated him from almost every other major designer of his era. He believed in wood. Not because wood was cheap, though it was. Not because Britain would run out of aluminum, though it might. He believed in wood because when properly engineered, wood could be lighter, smoother and aerodynamically cleaner than any metal airframe of the same size. And in aviation, cleaner meant faster. He had already proven this. In 1934, his company had built a DH-88 Comet, a sleek twin-engine racing aircraft built almost entirely of wood, designed to compete in the Mac Robertson air race from England to Australia. The Comet won. It was one of the fastest aircraft in the world at the time of its flight, and it demonstrated something that most engineers refused to accept. A properly designed wooden aircraft could outperform metal machines of far greater cost and complexity, so when war began to look inevitable, de Havilland proposed something extraordinary. He would build a bomber. Not a lumbering 4-engine heavy bomber like the ones being designed for Bomber Command, something completely different. A twin-engine bomber that would carry no defensive weapons at all. No gun turrets, no tail guns, nothing. The entire design philosophy rested on a single argument. If the aircraft was fast enough, high enough, and small enough, it would simply not need to defend itself. It would outrun anything the enemy could send to shoot it down. To make that possible, he proposed building the entire airframe out of wood. Sandwich construction, a layer of Ecuadorian balsa wood, extraordinarily light, glued between 2 layers of Canadian birch plywood. The fuselage would be built in 2 halves inside concrete moulds, then joined together like a giant model airplane, with all the wiring and controls installed while the 2 halves were still open. The result would be an aircraft so aerodynamically smooth that it could achieve speeds no metal bomber of similar size could match. He took the idea to the Air Ministry, and the Air Ministry in October 1938 rejected it. They rejected it not once, but multiple times over the following 2 years. The reasons they gave were consistent. First, they did not believe wood was a serious material for a modern warplane. Aluminum was the future. Wood was for peacetime civilian aircraft, for training gliders for the past. Second, they did not believe any bomber could survive without defensive armament. Every serious bomber design in every serious air force was moving toward heavier and more elaborate defensive gun installations. To propose a bomber with no guns at all was, in the eyes of most senior officers, either naive or insane. Third, in the middle of a national emergency when every factory in Britain was being ordered to focus on producing Spitfires, Hurricanes and the heavy bombers already in development, the idea of diverting resources into a strange wooden prototype seemed like a distraction the country could not afford. Lord Beaverbrook, the powerful newspaper baron who had been placed in charge of aircraft production, personally ordered work on the project, halted more than once. In official corridors, the aircraft acquired a nickname. It was called Freeman's Folly, after Air Chief Marshal Sir Wilfrid Freeman, one of the very few senior officials who saw what de Havilland saw and quietly kept protecting the project every time someone tried to kill it. Without Freeman, the Mosquito would have died on paper before it ever flew. Think about that for a moment. The aircraft that would end the war as one of the most decorated and successful designs in aviation history spent its first 2 years being treated as a personal embarrassment by a man in a Whitehall office. This is one of the recurring truths of engineering history. Some of the greatest ideas do not fail because they are wrong. They almost fail because the people in charge are certain, with total confidence, that they already know what a good idea looks like. But de Havilland refused to give up. He kept refining the design in secret, at his own expense, at a country house called Salisbury Hall, where a small team of engineers worked in near total isolation from the Air Ministry. And in the background, quietly, Freeman kept the project alive inside the ministry itself. The two sides were running a kind of guerrilla campaign, keeping a controversial airplane on life support while the war expanded around them. Then in the spring of 1940, everything changed. France collapsed. The British Army barely escaped from Dunkirk. Britain suddenly found itself alone, facing a German war machine that was preparing to invade. Aluminum was becoming precious. Skilled aviation labour was stretched to breaking point. And now, for the first time, the Air Ministry began to consider what had been unthinkable a year earlier. A wooden bomber, built by carpenters, using materials not needed for other aircraft, made suddenly by workers who were not currently employed in the aviation industry, started to look less like a folly and more like a lifeline. De Havilland got the order to build a prototype, and the prototype, when it flew, changed everything. The first Mosquito, serial number W450, took to the air on the 25th of November 1940. The test pilot was Geoffrey de Havilland Jr., the son of the man who had designed the aircraft. What he found in the air was almost hard to believe. The airplane was fast, really fast. In official trials at Boscombe Down, the standard performance testing site for the RAF, the Mosquito reached speeds of around 392 miles per hour. That number is worth pausing on. The Spitfire Mark V, one of the most celebrated fighters of the war at that moment, could not match that speed. A twin-engine wooden bomber, built by a company that many in the ministry considered eccentric, had just outrun Britain's most famous single-engine fighter. Later variants would push that number even higher. Some versions of the Mosquito were capable of over 415 miles per hour in level flight. Very few operational aircraft in the world could reach it, and none of them could catch it in a straight run at altitude. In 1941, the year it entered service, the Mosquito was arguably the fastest operational aircraft in the world. Its first operational sortie came on the 20th of September 1941, when a photo reconnaissance version flew over occupied France. 3 Messerschmitt Bf-109s attempted to intercept it at around 23,000 feet. The German pilots, flying one of the best fighters of the war, could not catch it. The Mosquito simply accelerated away and left them behind. This was the moment when the story stopped being about a strange experimental prototype and started becoming something else entirely. Because the RAF now had, sitting in its inventory, an aircraft with an almost science fiction combination of qualities. It could carry a serious bomb load, it could fly at extreme altitude, it could outrun every enemy fighter in the sky, it could be modified into a night fighter, a photo reconnaissance platform, a pathfinder for heavy bomber raids, a low-altitude precision attacker, an anti-shipping strike aircraft, or a long-range intruder. Almost every mission the RAF could imagine, the Mosquito could perform, often better than the specialised aircraft that had been designed only for that role. And now we come to the part of the story that gives this video its title, because the Mosquito was going to be needed in enormous numbers, and building thousands of wooden aircraft required an industrial base that Britain did not have inside its traditional aviation factories. So, de Havilland and the government made a decision that has become one of the most remarkable industrial stories of the entire war. They handed the aircraft over to Britain's furniture makers. Roughly 5,000 of the total 7,181 Mosquitoes produced during the war had their major structural components fabricated in and around the town of High Wycombe in Buckinghamshire. High Wycombe was not an aviation town, it was a furniture town. For generations, it had been the centre of British domestic furniture manufacturing. Chairs, tables, wardrobes, bedroom sets. The kind of woodwork that filled ordinary British homes. And now, in the middle of the war, roughly 20 furniture companies in and around High Wycombe were quietly converted into secret aircraft factories. The names of these companies, if you told them to an aviation historian in isolation, would sound absurd. Parker Knoll, E. Gomm, Harris Liebes. These were household names in British furniture, not in aviation, but their skilled woodworkers, their access to specialised woodworking tools, their generations of accumulated craftsmanship, made them uniquely suited to build an aircraft whose entire structure was a work of advanced carpentry. Elsewhere, other unlikely companies joined the effort. Addis, better known for making brushes and household products. Claude Butler, a bicycle manufacturer. Decca, better known for making records. All of them contributed components to what was arguably the most sophisticated wooden object ever built by human beings. The fuselage was built in 2 halves inside massive concrete moulds. Workers laid down thin sheets of birch plywood, then layers of balsa wood, then another skin of birch, gluing everything together with a specialised synthetic resin adhesive called aerolite. This glue, developed largely by a chemist named Norman de Bruyne, is one of the quiet miracles of the Mosquito story. Without a strong waterproof aviation-grade adhesive, wooden aircraft construction of this quality simply would not have been possible. The Germans would later try to build their own wooden fighter and would discover, painfully, that they did not have a glue anywhere near as reliable. But we will come back to that. Inside each concrete mould, roughly 6 workers could complete a full fuselage half in about a week. When the 2 halves were finished, they were joined together like the 2 halves of a violin. Before they were joined, workers installed cables, hydraulic lines, wiring and internal fittings, while the shell was still open. This allowed an extraordinary level of internal complexity to be built into the aircraft, with far less labour than a metal fuselage of comparable size. Now, the workers doing all of this were not the traditional aviation workforce. Many of them were women. In Britain, in Canada, and later in Australia, thousands of women were brought into the wartime workforce to build the Mosquito. In some factories, women were responsible for shaping and pressing the thin wooden veneers that formed the aircraft's outer skin. Some of them were still teenagers. Some of them had never worked in industry at all before the war. They learned quickly, and within a few years, this workforce, which included former furniture makers, piano makers, carpenters, cabinet makers, and countless women who had never held a factory tool before 1939, was producing thousands of the most advanced combat aircraft in the world. Meanwhile, the balsa wood at the heart of the Mosquito's construction came from Ecuador. This was not a trivial detail. It meant that every Mosquito ever built depended on cargo ships crossing the Atlantic Ocean in the middle of a submarine war. German U-boats hunted Allied shipping relentlessly. Every load of balsa that reached Britain represented a gamble that had paid off, and every load that was sunk represented lost aircraft that would never be built. The Mosquito was, in that sense, an aircraft whose supply chain reached across 2 oceans, through minefields and torpedo attacks, into workshops in a quiet English county. By the time the aircraft was in full service, it was doing things that no bomber had ever done before, and it was doing them with a survival rate that stunned everyone. Take the loss rates. Bomber Command's heavy aircraft, most famously the Avro Lancaster, were suffering brutal casualties over Germany. The Lancaster's loss rate was around 2.2% per sortie. That number sounds small until you remember that a bomber crew was expected to fly dozens of missions. Statistically, a Lancaster crewman had a heartbreakingly low chance of completing a full tour of operations without being killed, wounded, or captured. The math of the strategic bombing campaign was, in cold terms, a math of attrition. The Mosquito's loss rate was around 0.63% per sortie, roughly 1/3 of the loss rate of the heaviest bombers in the fleet. Mission after mission, the wooden aircraft that everyone had once considered a folly kept bringing its crews home alive. Not because it was armoured, because it was not. Not because it had heavy defensive guns, because it had none, but because it was fast enough, high enough, and quick enough that most enemy fighters simply could not get into position to shoot it down. This gets at the deeper genius of the design. In every other bomber philosophy of the era, defence was a matter of adding weight. Add more guns, add more armour, add more gunners, add more turrets. Each addition made the bomber heavier, slower, and, ironically, easier to catch. The Mosquito reversed the entire equation. Instead of trying to survive fighter attacks by fighting back, it tried to survive by not being caught. It removed weight instead of adding it. It stripped the aircraft of every defensive extra and used the savings to make it faster and higher flying than anything trying to intercept it. Speed itself became armour. Altitude itself became a defensive weapon. If you understand that single design idea, you understand 90% of the Mosquito's greatness. It was an airplane whose defence was the absence of defence, and once operational commanders realised what they had, they used it for missions that no other aircraft could have flown. The Mosquito became the RAF's precision instrument. It flew as a pathfinder, marking targets deep inside Germany for the heavy bombers that followed. It flew as a night fighter, hunting German bombers and later German night fighters, and destroying by some estimates over 600 enemy aircraft in that role. It flew as a photo reconnaissance platform, ranging deep into Axis-controlled Europe and returning with images that shaped Allied intelligence. It flew as a maritime strike aircraft, hunting German shipping in the North Sea and along the Norwegian coast, and it flew a series of low-level precision raids that even today, more than 80 years later, still sound almost impossible to have happened. The most famous of them was Operation Jericho. On the morning of the 18th of February 1944, a formation of Mosquitoes took off from RAF Hunsdon and flew across the English Channel at an altitude of just a few dozen feet above the ground. Their target was Amiens prison in occupied France, where the Gestapo was holding French resistance fighters, some of whom were scheduled to be executed. The mission was to breach the walls of the prison so precisely that the shockwave and the falling rubble would knock open the doors of the cells without killing the prisoners inside. It was one of the most delicate bombing missions ever attempted in the war. The Mosquitoes made their attack. They flew so low that they were passing under electrical lines. They dropped their bombs from a height of around 15 feet, using specially fused weapons designed to give the aircraft time to clear the blast. The prison walls were breached, prisoners escaped, though the operation was costly, and its outcome debated among historians to this day. One of the Mosquitoes was shot down. Its pilot, Group Captain Percy Pickard, one of the most respected officers in the RAF, was killed. Before the mission, Pickard had reportedly described the raid as, in his own words, a death or glory show. For him, it was both. There would be other raids like this on other targets. In April 1944, Mosquitoes attacked a Gestapo records building in The Hague, in the occupied Netherlands, flying their bombs directly through the windows and doors of the target. Civilians standing in a nearby breadline reportedly emerged from the raid without significant injury. It was a kind of precision no other bomber in the world could have achieved, and behind all of this, the Germans were becoming, quite literally, obsessed with the aircraft. Because the Mosquito was doing to them what nothing else in the war had been able to do. It was flying wherever it wanted, whenever it wanted, and coming home alive. In one meeting at his estate at Karinhall, Hermann Göring is reported to have exploded in front of his senior aircraft designers. His words, in translated versions passed down through decades of retelling, capture the frustration of a man watching his air force outmatched by a wooden airplane. He said, in effect, that it made him furious to see the Mosquito, that he turned green and yellow with envy, that the British, who could afford aluminum better than Germany could, had built a beautiful wooden aircraft that every piano factory over there was churning out. That last phrase was more true than Göring probably realised. Germany did try to build its own wooden high-speed aircraft, most famously the Focke-Wulf Tar 154, which was even nicknamed Mosquito, in a direct reference to its British inspiration. The project was rushed, and it ran catastrophically into the exact problem that de Havilland's team had already solved. It did not have the right glue. The specialised adhesive that had been developed for German wooden aircraft construction lost strength when it was exposed to certain conditions, and there are historical accounts suggesting that a British bombing raid destroyed a key glue production plant, forcing German engineers to switch to a substitute adhesive that was chemically unstable. Aircraft began to fall apart in flight. The TA-154 program collapsed. In one of the strangest ironies of the war, the RAF may have effectively bombed the German copy of the Mosquito out of existence, using Mosquitoes to do it. Meanwhile, the human cost of building this aircraft was not limited to the crews who flew it. Geoffrey de Havilland, the man behind the entire project, would lose one of his sons during the war years. John de Havilland, one of the company's test pilots, was killed in August 1943 when two Mosquitoes collided during a training flight. His father continued to run the company, continued to push the aircraft forward, continued to attend meetings, continued to sign off on new variants. Grief did not slow down the war. And in 1946, after the war had ended, Jeffrey's other son, Jeffrey de Havilland Jr., the pilot who had first flown the Mosquito, would also die in a test flight of a different experimental aircraft, the DH-108. 2 sons, both killed in the family business. The airplanes carried the family name forward. The father buried the men who had helped him build them. By the end of the war, 7,581 Mosquitoes had been built. It served in almost every theatre of the conflict. It flew from Britain, from North Africa, from Italy, from India, from Australia. It hunted U-boats, it intercepted V-1 flying bombs over the English Channel. It destroyed factories, marshalling yards, and communication centres deep inside Germany. It photographed the entire European battlefield from altitudes and speeds that made it almost impossible to intercept. And it did all of this while consistently maintaining one of the lowest loss rates of any combat aircraft in the war. After the war, the Mosquito continued to serve for years in air forces around the world. It was used as a photo reconnaissance platform, a night fighter, a training aircraft, and a target tug well into the 1950s, but its era was ending. The age of the piston engine warplane was closing. Jets were taking over. The very design philosophy that had made the Mosquito revolutionary in 1940 was, by 1955, quietly being retired. Today, fewer than 35 complete Mosquitoes are believed to exist anywhere in the world. Only a handful of them are in flying condition. The original prototype, W4 is preserved at the de Havilland Aircraft Museum in Hertfordshire, England, in the very grounds of Salisbury Hall, where the design was first drawn up in secret. If you visit that museum, you can stand a few feet away from an aircraft whose entire structure was condemned by the Air Ministry, was ridiculed as Freeman's Folly, was rejected multiple times by the very government that would later depend on it, and which went on to become one of the most important aircraft of the entire war. So what is the real lesson of the Mosquito? On the surface, it is a story about wood beating metal, about furniture makers outperforming aviation engineers, about a rejected idea proving its critics wrong. All of that is true, but underneath there is something deeper. The Mosquito is really a story about a specific kind of engineering courage. It is a story about designers who were willing to remove things instead of add them. Almost every other bomber program in the world in 1940 was asking the same question. What more can we bolt onto this aircraft to make it survive? More guns, more armour, more gunners, more turrets. De Havilland asked the opposite question. What can we take away? What if we do not need any of it? What if speed itself, if pushed far enough, becomes its own defence? That question was heresy in 1938. It was a joke in 1939. By 1941, it was flying operational missions faster than the Spitfire. By 1943, it was interrupting Göring's speeches over Berlin. By 1944, it was breaking down the walls of Nazi prisons at 15 feet of altitude. And by 1945, it had one of the lowest loss rates of any aircraft in Bomber Command. Having proven, mission after mission, that the men who had once called it Freeman's Folly had been wrong about almost everything they thought they knew. Sometimes the strongest aircraft in the sky is not the one carrying the most weight. Sometimes the deadliest weapon is the one that refuses to fight in the way everybody else has agreed it must be fought. And sometimes the machine that ends up embarrassing the most feared air force in the world is a wooden airplane glued together in a furniture town in Buckinghamshire by carpenters and cabinet makers and teenage girls who had 3 years earlier been making chairs. The Mosquito did not win the Second World War on its own. No single aircraft did. But among all the machines that flew in that conflict, few embodied so completely the idea that ingenuity, at its rarest and most fearless, is more valuable than raw industrial power. The Germans had more aluminum, they had more factories, they had in many technical fields more advanced engineering. And yet, when they tried to build their own wooden speed bomber, The glue failed and the aircraft came apart. Britain got the glue right. Britain got the wood right. Britain got the geometry right. Britain got the philosophy right. And in doing so, Britain took an entire industry that had nothing to do with aviation and turned it into one of the most quietly decisive assets of the entire war. If you look closely at any Mosquito that still survives today, you can see the grain of the wood beneath the paint. You can see the joints where a birch skin was pressed and glued to a balsa core. You can see, if you know where to look, the workmanship of people whose real profession was building furniture for ordinary British homes. Their hands built an airplane that outran the Luftwaffe. Their tools produced a machine that interrupted Nazi propaganda broadcasts in real time. Their skills, unnoticed and unglamorous, helped shape the outcome of a global war. The Mosquito was never really a warplane, in the way most warplanes are warplanes. It was a beautifully engineered idea, wrapped around 2 Rolls-Royce Merlin engines, delivered to the world by a company that believed in wood, and built, in the end, by a country that had almost thrown the entire concept away. If stories like this interest you, the history of aviation is full of aircraft that were built by the wrong people, in the wrong places, using the wrong materials, and ended up rewriting the rules of everything that came after them. The Mosquito was one of the strangest, one of the boldest, and one of the most successful, and nearly every part of it, from the balsa in its walls, to the birch in its skin, to the wooden ribs inside its wings, was originally destined to become somebody's dining table.